Hello and welcome to part 9 of the chapter Triangles. We were solving radius. So far we have solved 3 radius and the fourth one was given for the homework. Let's go through the homework first. Very short question. In triangle ABC, AD is perpendicular to BC. Prove that AB square plus CD square is equal to AC square plus DB square. Now, if you look at the two right angle triangle, that is one is ADB, another is ADC. They have a common side AD, and that AD is not there in the final statement. So here is a hint. So we'll write two equations with AD square on the left hand side, and we'll equate the right hand side. Let's see the proof. First, apply Pythagoras theorem to right triangle ADB. So we get AD square plus DB square is equal to AB square. So keep AD square on the same side. You will get AB square minus DB square from statement 1. Consider other right angle triangle, that is ADC. Apply Pythagoras theorem. You will get AD square plus CD square is equal to AC square. Now keep AD square on the same side and take CD square on the other side. You will get AD square is equal to AC square minus CD square. Look at statement 2 and statement 4. The left hand sides are AD square. So you can equate the right hand sides of the two statements. That is AB square minus DB square is equal to AC square minus CD square. What we want, look at what is asked to prove. It is AB square plus CD square. The CD square is here. So which can be taken on the other side, it will be plus CD square. On the right hand side of what is asked to prove, AC square is already there. Only we want plus DB square, which is here. On the left hand side, minus DB square. When you take it on the right hand side, it will become plus, and we will get the final statement. So very simple rider. As I mentioned last time, I have taken this from the model paper, this year's model paper of Goa board, and this rider is for 2 marks. Now let's go to the fifth rider, little difficult one than this. We'll read the question along with the figure. In the adjoining figure, the perpendicular from A on side BC of triangle ABC intersect BC at D such that DB is 3 times CD. So D to B is 3 times C to D, or CD is 1/3 of BC or BD or DB. Let's see what is asked to prove. 2AB square is equal to 2AC square plus BC square. Okay, so on the left hand side there is AB square is there. So AB is the hypotenuse. So there is no problem. We can start the proof with Pythagoras theorem. In right triangle ADB, AB square is equal to AD square plus BD square. Now if you look at the statement 1 and what is asked to prove carefully, the AD which is there in statement 1 we don't want. We want AC. So if we consider right angle triangle ADC, we can write in place of height square is equal to hypotenuse square minus base square. I'll show you the second statement. AB square is equal to AC square minus CD square. That is height square is equal to hypotenuse square minus base square. We have applied Pythagoras theorem in right triangle ADC. We'll remove the bracket. And now AB square is equal to AC square. Now CD is there and BD is there. We have to express this both in terms of BC. Now CD is 1/3 of dB, or dB is 3 times CD. That means the base BC is divided into 4 parts. One part is CD and there are 3 parts on other side, that is dB. So when you want to replace CD, it is 1/4 of BC and BD will be 3/4. There are 3 parts, 3/4 of BC. Let's see the next statement. AB square is equal to AC square minus 1/4 BC square, because it is 1/4. In place of BD, it is 3/4 BC square. The reason is obvious, it is given that dB is 3 times CD. So when you square, don't forget to square the 1/4 and 3/4 also. AB square is equal to AC square minus BC square upon 16 plus 9/16 BC square. We will multiply throughout by 16. So we will get 16 AB square is equal to 16 AC square. 16 will get cancelled. You will get only minus BC square plus 9 BC square, because 16 again will get cancelled. Now it is simple mathematics. 16 AB square is equal to 16 AC square minus 1 plus 9 is plus 8 BC square. Divide throughout by 8, we will get the final result. 2AB square is equal to 2AC square plus BC square. The two very important things. You should find a hint, if there are any hints, especially from what is asked to prove. There you can get some hints, and you should know the basic concepts very well. For example, here CD is 1/3 of BD, means it is 1/4 of BC. So such things we should know. Let's go to the next rider. Sixth one, we'll see the figure also. Triangle XYZ is an equilateral triangle. XA is perpendicular to YZ and B is the midpoint of AZ. Now, as far as equilateral triangle is concerned, I will just go through one concept of equilateral triangle. In equilateral triangle AYZ, AB is the altitude drawn, that is perpendicular, and if we look at the two right angles which are formed here, XAY and XAZ, there is a right angle in each triangle. XA is the common side and XY and XZ are equal because triangle is equilateral. Therefore, the two triangles which are formed here are congruent by RHS. That means AY is equal to AZ. That is, A is the midpoint of YZ. And the concept is, in an equilateral triangle, altitudes drawn on any side are same as medians. This concept you should know to proceed further. Okay. Further, it is given that A is the midpoint because altitude is the median, and B is also the midpoint here, that is given of AZ. So let's see what is asked to prove. XB square is equal to 13 BZ square. Well, B is a hypotenuse, so there is no much problem to start with. Apply Pythagoras theorem in triangle XAB. XB square is equal to XA square plus AB square. We don't want XA in the final statement. So we'll go to XY because XY and YZ are equal. Now in place of XA, we can get XY. Again, Pythagoras theorem, height square is equal to hypotenuse square minus base square. XY square minus YA square, that is hypotenuse square minus base square, is equal to height square XA square. We have used Pythagoras theorem in triangle, right angled triangle XYA. We'll remove the bracket. And now see, XB square is equal to XY square minus YA square plus AB square. And if we want only BZ, so we will express everything in terms of BZ. So first of all, that XA we can replace by YZ. Yes, because XYZ is an equilateral triangle. Now, we'll go on replacing with BZ. Now, A is the midpoint of YZ and B is the midpoint of AZ. Therefore, relation between BZ and YZ is 4 times BZ. So, in place of YZ, we will write 4 times BZ. In place of YA, because YA is equal to ZA and B is the midpoint again of AZ. So in place of YA, we can write 2 times BZ. And in place of AB, we can write BZ because both are equal. B is the midpoint of AZ. Let's see the next step. It will be more clear. XB square. So in place of YZ, it is 4 times BZ whole square. Minus in place of YA, it is 2 times BZ whole square plus BZ whole square. So A is the midpoint of YZ and B is the midpoint of AZ. So we'll get XB square is equal to 16 BZ square minus 4 BZ square plus BZ square from statement 5. And when you simplify, please do the correction here. It is XB square is equal to 16 minus 4 plus 1 is 13 BZ square. So only you should express that YZ, YA, AB in terms of BZ. That is the fifth step is the only difficult step. Rest, if you see everything, it is just Pythagoras theorem and we have used equilateral triangle that sides are equal. We'll solve one more rider based on equilateral triangle. There is a footnote here. In an equilateral triangle, the altitude and a median are same. We'll see the figure. In an equilateral triangle ABC, D is a point on side BC such that BD is 1/3 BC. That is, other words, BC, the side is 3 times that part, that is BD. And AE is also perpendicular to BC. Again, in the equilateral triangle, we have altitude. So E is the midpoint of BC. Let's see what is asked to prove. 9AD square is equal to 7AB square. Fine. AD is the hypotenuse. So we can start. AD square is equal to AE square plus ED square. So in the final statement, we don't want AE. So we can write that height square is equal to hypotenuse square minus base square in right angle triangle AEB. So we will get in place of AE, we'll get AB square minus EB square plus ED square. We'll remove the bracket. So you get AD square is equal to AB square. We already got AB. We want AB only on the left hand side, right hand side. Now there is EB and ED. So we have to express this EB and ED in terms of BC. And once we express that in terms of BC, BC and AB are equal. So we can write AB. Now EB is very simple. It is half of BC. But ED is little difficult. If you look at the ED, it is B to E minus B to D. B to E is half BC and B to D is 1/3 BC. 1/3 is given. That means ED part which is there, it is half minus 1/3 BC. I'll explain once again. ED is equal to BE, which is half of BC, and minus BD, which is 1/3 of BC. We'll see the statement. AD square is equal to AB square minus half BC square. Now, in place of ED is half minus 1/3. Half BC minus 1/3 BC whole square. And when you simplify, you get AD square is equal to AB square. That half BC square becomes 1/4 BC square. And that is half minus 1/3 is 1/6. And square of 1/6 is 1/36 BC square. We will multiply throughout by 36. And we will get 36 AD square is equal to 36 AB square minus that is 4 9s are 36, so 9 BC square, and 36 gets cancelled and you get BC square. Now in the next step, the BC can be replaced by AB because they're equal. Yes. And now it is simple mathematics. We get 36 AD square is equal to 36 minus 9, which is 27, plus 1 is 28. Both are the multiples of 4, so you can cancel. 4 9s are 36, 4 7s are 28, and here is your final statement. The only difficult part here is that ED. Look at that ED very carefully. ED is BC minus BD, BE is half BC, and BD is 1/3 BC. So you get 1/6. That ED part is 1/6 of BC. Now it's the time for the homework. Let's see the question. In triangle ABC, AB is equal to AC. That means triangle is isosceles and AE is perpendicular to BC. Here is a perpendicular on the base in the isosceles triangle, and on the base when you draw the perpendicular, this altitude is also the median. So E is the midpoint of BC. D is any point on BC, and then you are asked to prove AB square minus AD square is equal to CD into BD. So I'll give a hint also here. AB and AD, they are both the hypotenuse. So you can write two statements and subtract them. Subtract second from first. You will get your left hand side. And then try to get your right hand side, because there is a hint here that perpendicular drawn on the base bisects the base. Try this at home. I'll solve this in the next video. That's all for today. See you again.